right, so I apologize for the 1.5 million notifications that you got on Discord. As you may have seen, we had somebody decided to send out our invite to a bunch of people who decided to raid our Discord server this morning. That's a mild irritation to me. I don't know who did it. Honestly, I don't really care. It's a mild irritation to me at most. I've been on the internet much longer than any of you have, and I've seen much worse. So you really can't hurt me. But boy, does it make it angry when you can potentially hurt my students. Don't do that again. I get really pissed off at people who mess with my students. Ask the financial aid office. Okay? So that's what annoys me. I'm sorry that for students, if you saw anything that really upset you. Again, we kind of took care of it. I've added moderators. I try to make it as seamless as a joining process for everybody. So, yeah. Anyway, if you have any issues with, if you see any issues with that, feel free to ping me. I was in Japanese class at the time, so that's why I didn't see any of the notifications people were getting me. So as soon as I got out, I saw it, and it got handled. So, right, if anybody has any concerns or anything, or frustrations, please let me know. I'll be happy to listen to you, but I'm sorry that if you saw anything that really upset you, that stuff is not stuff I condone. I try to make sure that this stuff doesn't happen on the server, and so we've put in more stringent rules about that. Okay? Now, with regards to what's going on in the upcoming days, so first off, let's go ahead and just take care of administrative stuff. Okay, over here is, so if you click on lecture recordings, because you may have not seen what I just did there, if you click over here on lecture recordings, or down here under other important links, if you click on lecture recordings over here, right, then that will bring you to this page on YouTube, this page of embedded YouTube's videos. I've started uploading the lectures in a playlist, so they're all collected over here. So if you weren't here for lecture one or two, please review what was here. Okay. If you've just joined, just send me an email if you want to join the Discord, because I've revoked all the permissions for the invites, obviously. That makes a very easy way to stop that kind of stuff. So just let me know and I can get you in. Let's see. All right, so Lab 1 is due today. So I'm sure a lot of you are concerned because oh no, I didn't get the chance to demo it. But if you haven't gotten the chance to demo it, please keep in mind that you are allowed that you don't have to demo it by the due date. You have until 2 weeks after the due date to demo it. Okay? So we only ask that you turn it in by the due date. That's what determines whether it's late or not. Okay? So you don't have to worry about that if you've done it. You can either demo it during office hours or you can demo it during the lab session. One of our TAs was sick, so she held her lab virtually this morning, I believe, over Zoom. You should have gotten that email if you were in her section. If you are, I'll double check to make sure that got there. Did anybody try to go to lab today and there was nobody there? So just did you get the email or no?
So I have to look at announcements for it.
Interesting. Okay, I will double check to make sure that let me add that to make sure that the that the TAs are attached to the appropriate sections of the emails will go out via announcement. That may have been an issue because there was an issue this semester. It's never happened before where the TAs did not get automatically enrolled into the Canvas course. That was the issue I had today, or this semester. So let me make sure TAs are in correct section. Sorry about that. All right. So if you need me to walk you through that homework, please let me know. This is our first like actual homework as opposed to the first one, which is just making sure that Python is working. Again, if you're stuck on that, please let me know. I will help you through that either via email or just, again, send me a message. Okay. So that's what we are. So that's what that should take care of all the administrative stuff. Once again, your first exam is not soon. It is week 6, most likely. So if this is currently week 2, so you've got plenty of time in case you're just curious as to when that is. But I figure I should let you know because week 4 is when you should start thinking about it, and obviously week 5 is when you should start panicking about it, right? No, don't panic about it. Just let it know. A lot of you are fall freshmen, which means that you're new to the whole college thing. So you got to understand that now that you're more kind of in an independent situation than you were, that you're much more subjective. You're much more likely to be subjected to Murphy's Law. So does everybody know what Murphy's Law is? All right, Murphy's Law is the one ironclad truth in this universe, which is anything that can go wrong will go wrong. And it happens to us doing programming a lot. Users are great at finding bugs and that you never knew could possibly happen. So whatever can go wrong will go wrong. So with regards to studying, my one piece of advice coming from somebody who suffered as a bad student for the first 2 years of undergraduate until I finally got a hang of things, if you've got an exam like on a Wednesday, make sure you finish your studies by like Monday, because inevitably Tuesday is when things are going to go wrong and prevent you from studying. So basically just plan for things to go wrong like the day before, the day before your exams, that exam is. I swear it's like happened to me like during half the exams I've taken. So just keep that in mind. And if you plan for, and if it doesn't turn out to be that way, great, you're done studying. You just have to do a light review. Okay. But again, yeah, it can, so try to your best not to fall behind. Also note, so now let's go ahead and talk about what we're going to do today. So once again, you can find out what we're doing week by week by going to the modules, where I try to go over it. I'll be sending out a pre-knowledge quiz this later this week, like either tomorrow or tonight. This quiz is extra credit. It's worth 5 points of extra credit on your in-class exercises, essentially. So it's not much, but it's 3 points if you take it. And the reason I'm giving you it's worth extra credit is because I don't want you to cheat on it. I want you to actually know. I'm trying to measure, okay, what do you actually know before you go in? So I can measure afterwards what you know at the end of the course. So it helps us collect data, is the point. Okay, now the idea here is that just you'll have some code, it will ask you what to do. Don't run the code. Just answer the best of your abilities. You're going to get the same amount of points whether it's right or wrong. Okay? It's completely optional, but I do incentivize you to take it. But you'll be getting that later. Also expect a survey. I'm in part of a research group, and that survey helps our research. So expect that. I know you're probably going to get bombarded by surveys, but please know that this survey that we'll be sending out is really important to me. And the more of you who are able to fill it out, that'd be awesome. There's no extra credit attached to the survey because that is completely anonymous. So regardless, that should cover it. So again, let's go back to our modules. Over here, overview. So we'll be so here we are going to be talking about variables and talking about mathematical operations a lot. Lab 2 this week, which we'll be doing in Lab 2, is Messy Chocolate, which is 4 different exercises. Now, for those of you who should have had Lab Monday, you will do Lab 2 on this upcoming Monday. And then you'll do Lab 3 on the Monday of week 4. Think of it as your lab now, basically, as your lecture now being before your lab, as opposed to your lab being before your lecture. So your week starts on Tuesday, in other words. It's weird, but it's also just the way that Temple schedules things, because your last week of classes is like a final Monday class, and then 2 study days, and then beginning of finals. So it does work out in the end. So there's 4 separate Python programs. I request that you do them as 4 separate Python programs. If you know functions, I guess you can do it that way. That's fine. The first is using the Harris-Benedict equation, which is very basic. It was invented decades upon decades ago, which is why it's worded the way it is for BMR, but it's a very quick way to do BMR calculations. And what we're interested in is if you did nothing but stay in bed and eat chocolate, how much chocolate would you need to maintain your weight? I know, living the dream there, right? So you don't need to ask for the user's gender. I just want you to print out both male and female there, okay? This one, I've got this file which will not work. Your output should be 139 when 12 is entered in this code, so basically fix this code. If you're not sure what's up with it, just read the documentation. This one, very basic exercise that we do in pretty much every beginning programming class, which is a temperature converter, Celsius to Fahrenheit in this case. In this case, depending on how you do it, you might have some some jitter from conversion. Like you might convert it and it might say 98.600000003 or something like that. If that happens, don't worry about it. You got the 98.6 part, and that's just doubles being wonky. And then finally, this is probably the most logically challenging, which is seconds to hours, but that should help. But what we're going over today should help, which is ask the user for seconds and calculate how many hours, how many minutes, and how many seconds are in that. Okay. Now, the tools for that are creating new variables, using division, and using modular division, which, if you remember from me briefly mentioning it and your readings, is that percentage sign symbol. It's the operator that gives you the remainder. Now we're going to use that today in our in-class exercise. So once again, for now, let's go ahead and get everybody to pull that up. Again, if you don't have a laptop, pair with somebody who does. But we're going to be going over Project 2 on Runestone. So open up runestone.academy, your textbook, log into it, and then over here, right, it should be over here under Week 2, Part 1 in class. So you'll want to click this, or you can go to Foundations of Python Programming, your textbook over here, and drag it all the way down. Oh, it's not over that one. Okay, we're going to do turtles instead. That sounds good. Turtles are fun. And we're going to yeah, that makes sense. We're going to go all the way down to turtles. Now, turtles are pretty useful. So, sorry, the modular stuff will happen on Thursday. I got my days confused. Let's see. I see. Okay, yeah, you'll definitely want to go to this page over here don't go over here. Instead, go to Foundations of Python Programming, click on it, go all the way down to Project 2 at the bottom of the page. Or you can go to Canvas, click on Modules, click on Module 2 Overview. Let's see, did I change that link? Yes, I did. All right. Yep. All right. Now, before we get started on introducing turtles to you, Are there any questions so far about the class or any of the content that you've read? Any questions about anything? Python, why we're doing what we're doing? Anything? Yes?
So when it comes to dividing numbers in Python, how would we get it to round them if we needed it to round them?
There's an excellent question. There's a math library in Python that will learn how to import, but you import it by saying import math. And then you can use its functions by doing math dot and then the function you want. Math has a bunch of useful functions such as ceiling and floor, which you round up and round down no matter what. Like if you have a bit more than a zero, if it's a decimal, if you have 91.1, ceiling will round that up to 91, right? But all the rounding functions are in Python, are built into the Python library if you want it. It's an excellent question. Okay. Okay. All right. So today we're going to talk about I'm going to introduce you to turtles and I'll do that before I talk about the review session that will help you with, before I talk about stuff that's going to help you with your homework in this lab. Okay. So turtles are what we're going to be utilizing in Python to do basically to do a lot of our first labs. Labs 3 involves turtles. Labs 4 involves Labs 4 and 5, which is a single assignment that spans 2 weeks because it's a large assignment. I figured it's a lot of smaller exercises. That's turtles. Lab 6 is not turtles, but Lab 7, the hurricane tracker, is a turtle exercise where we build a hurricane tracker. Sounds a lot more complicated than. It sounds complicated, but believe it or not, once you got the components working, it's actually fairly straightforward. So turtles is a paradigm that was created for the Logos language in the 60s, I believe. It's fairly straightforward, but the idea here is that it was designed to teach children how to program. And I'm using it here because it's good at what it does. A lot of programming things that were designed for children for teaching children how to code are actually really good pedagogically. Like the other one that's designed for children that's really good is MIT's Scratch, which is really good. It's this block-based coding thing where basically you create code by dragging these blocks what ends up being code and locking them into place. This is such an effective teaching tool that Harvard uses this in its intro class for the first lecture to introduce programming. So don't be insulted when I'm saying it's designed for children. What this means is that if you're trying to build a game using turtles, probably better off using a different tool. Turtles is meant to help being a visual aid to understanding what's going on. And again, your textbook's pretty awesome here because I can just hit a button and it runs a graphical program, this turtle program, in the middle of it. So here I'm going to talk about now there's two pieces of black magic that I have to go over here, basically things that are arcane, and I have to say, and this does this, and don't worry about how it works. That's it. Everything else is fairly straightforward. So let's go over those two lines now. The first is import turtle. That's not too bad. You'll be learning about imports in chapter 3 or 4. That basically says, hey, I want this program to utilize the turtle library. Now, libraries are batches of code that are designed to make your life easier, so you don't have to build everything from scratch. For instance, there's an import, I think, HTTP server, which allows you to basically run a web server using Python and receive and send HTTP requests, which are requests for internet connections and transmitting pages. Because Python is useful like that and has those libraries built in. But not every program needs to have access to everything loaded up, right? When we boot up idle, there's a little delay because it's loading up the libraries that are needed for Python to run. So if we loaded up every library that in existence, that would take forever. So we only load up, well, it only loads up in minimal amounts, variables, the ability to add, and the ability to do basic numeric calculations and that kind of stuff. Graphics, not every program needs, so it doesn't bother loading that up. So we're saying, hey, import turtle so I can use turtles. Okay, that's it. It's fairly easy to understand. Now, line 3 over here, because it's just custom to put a gap between import and everything else, is our line where I'm just going to say, and this magically works. My turtle equals turtle.turtle. Notice the lowercase turtle over here and the uppercase turtle over here. Okay? That is how that works. This says in the comments over here, create a turtle. So there's a lot going on here. Let's start with the comments. Comments, if you haven't seen them yet, are wonderful and magical. Okay? Now, you're very good at programming. But you, a week from the past, you were very bad at programming and possibly insane. Very bad. You were not a good programmer last week. And that's true for any time you're programming. So a couple weeks from, if you're week 7 programmers, when you're in week 7 you is going to be great. Week 6 of you is going to be like, what was week 6 doing? You can't remember what you were doing. It was a lot of work. Comments are a way for you to mitigate that. The fact that, you can't remember what you were doing last week. Okay? And what a comment is that you see this pound sign or hash mark or whatever you want to call it, right? The number sign, right? This sign, it basically says, hey, computer, everything over here is for human eyes only. Don't try to execute it. It's not human, it's not code. So anything after this is, the interpreter looks at it and goes, whatever, it's just human stuff, don't need it. You can either put it over, at the end of a line. I like to put mine at the top of my lines. Like, and to kind of break it up into paragraphs. They're very useful. Be sure to use comments. When you find you want to remind yourself, what you were doing. This is very useful, by the way, if you're afraid of demoing and afraid of explaining something, because you can just write your explanation right in front of you, and bring it when you demo it. Hey, it's right there in the source code. You've got it explained. So use comments to your advantage. So turtle.turtle creates a new turtle. Now there's a few ways to look at what we're doing here. There's a few different ways to look at it. One way to look at it is that we are creating a box called myTurtle, and we're putting this turtle object we create into the box. There's multiple layers of abstraction going on here, which is why there's multiple ways to look at it. And again, remember, this assignment statement is more like a directional arrow. It says, hey, we're taking this and we're storing it in, and we're doing this, and the result gets stored in myTurtle. Okay? And this means that, or another way to look at this is that this turtle is now wearing a name tag called myTurtle. So whenever I want to refer to this bit of memory, this bit of this little program that I created out of the ether, I just simply call it myTurtle. And that's it for basically the parts that don't necessarily make any sense. These are the 2 lines that you need to know how to do to do your magic. Now you don't have to call it myTurtle. In fact, normally the variable I use is Bob, because it's 3 letters and a name. So we'll see Bob in a bit. So myTurtle. So let's go through the rest of the code. It says myTurtle.colorGreen. Pretty straightforward guess as to what this one does, especially set the color. It changes the turtle to green. There's a bunch of different pre-programmed color. The common ones, blue, yellow, green, gray, black, white, and that will change the color of the turtle, as you can see here. And now, the next command, myturtle.forward50. Draw a green line of length 50. So now here's the other use of comments that I'm about to do. I am commenting out the code here. This is very useful if you want to temporarily disable code, where you just put a comment sign in front of it and that tells the computer, hey, all this stuff over here is over for humans. It's not, but basically it's a way to turn off that code, essentially. So now we're only going to do these 4 lines, which is to change the color to green, make the turtle change the color to green, and move it forward 50. And that way we can see that it has moved the turtle forward 50. Okay? Now, the way the turtle paradigm works is that we are viewing the turtle from the top looking down. We've got a bird's eye view of the turtle. Okay? Okay, in fact, let's go ahead and make it a bit more of a turtle. Python turtle. I always have to look this up, so don't feel bad about having to look specific stuff up. I always have to look up the exact names. Set shape, I believe, or what's it called? Shape? Is it just simply? Let's see. How do I do it? Turtle.shape. Okay, great. So let's go ahead and make this turtle a bit more turtley. It's called myturtle.shape. Don't make this mistake. There's one annoying thing with Pythons and turtles. Just don't, after you use turtle over here, don't use turtle again. Always use myturtle. Turtle.shape. Turtle. Guess what that does? So now let's run it. Notice that I use single quotes over here and, double quotes over here and single quotes over here. Python doesn't care. Quotes are quotes. Python doesn't care. Okay? So now, there we go. That's a turtle. All right, so we're looking down at this turtle. And the paradigm here is that the turtle is dragging a pen in his mouth or on his tail, depends on how you want to look at it. He's on a big canvas of white paper, and he's dragging a marker or a pen along with him. Okay? So by telling him to move forward 50, that tells him to move forward 50 pixels, and he leaves a streak right there. Okay? Very straightforward kind of deal there. If I told him to move 100 instead, my turtle.forward 100, you can do that. But Professor Rosen, you may say, I'm lazy. I don't like typing forward. And I keep forgetting that there's an R or W in there. Sorry, I keep forgetting there's an R in there, and I'm bad at spelling. Okay, don't worry, I'm lazy too. You can also use FD for forward. It does the same thing. It's just a renaming. So I would use forward, but hey, it exists. Okay. Now you can chain this. You can chain this together. You can go forward 50 and forward again, but whatever. Now let's go ahead to these next 2 lines over here. myturtle.up and myturtle.forward 50. We've already seen what myturtle.forward 50 does. It moves the turtle forward 50. Here, if we look on the comments on line 7, it says myturtle.up says lift up the tail. So if we run it now, we see that the turtle has moved forward 50, and it's moving too fast for me right now. The program runs a bit too fast for me now to scroll down and catch it while it's moving. But it moved forward 50, and then we told it turtle.up, and then we moved forward again. So what turtle.up does is that it lifts the tail up. In other words, it lifts the pen up, right? So it doesn't mean move up. It tells it to lift it up or put it so that it doesn't draw anymore. This is useful if you want to create spacing, right? Rather than it being like one long kind of just drawing of a single like line or curve, right? Up is short for pen up, right? So it does the same thing as pen up. Again, lift the pen up. And obviously, we can also put it down. Okay, now for the rest. Right 90, down, and backward. It's pretty easy to figure out what all that does. Right receives 90. Now, when we're talking about the commands left and right, that's turning the turtle. Left and right don't move, left, right, up, down, those don't move the turtle. The turtle only moves forward and backwards. That's a lie. It can do one more other thing, but I'll get into that. But in terms of like directly controlling it in the way we want you to control the turtle, forward and backwards is the only way it moves. Up and down lifts the tail. Left and right turns it left and right by degrees. And we've been using degrees for a while in algebra, so you should be fairly familiar with it. Right? 90-degree turn is basically, 90-degree turn to the right. If I'm facing this way, it's now this way. Nothing to panic about. So that allows it to turn and then change the direction it's drawing. Down puts the pen down, and backwards moves the pen, moves the turtle backwards. So we'll see. So it moved forward 50, right? That's the green streak. Then you've got a white gap where it lifted up the tail, moved forward another 50. Then it turned to the right and moved up. And moved backwards, basically in the north direction. So turtles always face east to begin with. They always face the direction. Another way to think of it is it always faces the direction of x positive. This is a coordinate plane, which is useful. And fortunately, it's not one of the funky computer science coordinate planes that you may be used to if you've come from another class and had to deal with graphics. That's annoying. We don't want to have to teach you a coordinate plane to do graphics. So we're just using the coordinate plane you know. The center of the screen is 0, 0. You can figure the rest out from there, right? Going up is positive y, going down is negative y. Going to the left is negative x, positive x. So there are commands we can use here. Let's go ahead and, I'm going to go ahead and now comment this all out using something called a multi-line quote. So this is not really a comment, but it acts like a comment. What I did is I used 3 parentheses, okay? Sorry, it's not 3 parentheses, three quotation marks. Let me show you. Print, this is a triple quote in action. So normally when you print something, when you try to do a string, you can't split the string across lines. But sometimes it's just so much easier to split that string across lines. So you run it. It didn't like it because I imported the turtle and didn't use it. That's fine. But now notice this is a triple quote in action. This string was able to go across lines because I used triple quote. So that's a triple quote string. That's really useful when you want to, when you're like, no, it needs to be literally printed like this. I don't want to have to deal with new lines or any multiple print lines or any shenanigans like that. However, that's not how it's usually used. Typically what we do with it is to just comment out a lot of lines of text. What this did over here is that this turned everything between the triple quotes into a string that never set it to a variable. So it's just kind of, okay, and here's, it's like putting the number 5 in your code. It doesn't do anything. It's like creating a variable and just not doing anything with it. That's what it does over here. And that way, just a quick way to kind of, again, turn off that code without deleting it. So let's go ahead and review. How do I create a turtle? I say, I create a name tag that I want to use for this turtle. I'm going to use Bob now because Bob is easy to type. And I say turtle on all lowercase dot turtle with the capital casing there, right? Capitalize the T there. That is the magic command that creates a new turtle. Why is it like that? Because this first, a lowercase turtle, is the turtle package. And the second one, which is uppercased over here, the one that has the capital T, that says, okay, the turtle package, the dot says look inside of it, and there's a function in there, something that's technically called a constructor, that makes us a new turtle object. Now, objects are, again, these nouns when they're in programming. They have a whole lot attached to them, like it keeps track of what color it is, where it is, and what it can do. So Bob is now our new turtle. And yeah, the memory location of this is stored inside Bob, but it might just be easier for now to think it's a name tag on top of Bob, because it could have multiple name tags. You can wear multiple name tags, no problem. So think of it like that. It's a name tag right now. Now to get him to move, I say Bob dot forward. Or backwards, it doesn't matter. 50. And there we go. Now your turtle starts out black and shaped like an arrow. Boring. We can change his shape by saying Bob.turtle. Sorry, Bob.shape. And then what shape you want. There's a bunch of different shapes. You also, if you ever work on this on your own computer as opposed to in the web browser, you can take images and register those as shapes and like make your turtle a custom shape. For instance, in our hurricane tracker program, we set up the turtle to look like a hurricane, the symbol of a hurricane. So there we go. Bob.shape turtle. And there we go. We can run it and see that it's shaped like a turtle again. Right? Now, I mentioned that this is a coordinate plane, and there was one other way to move, and that is by saying go to. It's considered harmful if you know that reference, which is a deep reference, but never mind. Go to, and then you provide the coordinates that you want. Like, let's go with negative 100 and 100. So negative x1, so this is an xy coordinate, right? Negative 100 on the x plane, on the x direction, and then 100 on the y direction. And so you see, it moved forward 50, and then we told it to move to an exact location in this square. Negative 100 in the x direction. You can see it's no longer in the center. And up 100 in the y direction. Right? So it's just the coordinate plane that you've been using since you've had to use graphs. Right? So that's not too scary. Now this is great if you know like exactly how you want to draw stuff. So that can be, but otherwise, sometimes you want your turtle to be, moving in relative directions. Now, there are some other things so far we've seen what we can do for drawing with the turtle. There is one more thing we can do to have the turtle draw stuff, which is we can do so here I remove the go to. I'm doing Bob.up to lift up the tail. Right, so here, let's go ahead and change that around. So now shape, register the turtle, go forward, lift up the tail, Bob. Yeah, here's what we're going to do. So here, I've changed up the order quite a bit. Create the turtle, change the shape to a turtle, tell him to lift up his tail immediately, tell him to move forward 50 pixels. New command here, Bob.stamp. Be sure to spell it correctly, unlike what I did there. And then I will copy paste this again. Take lines 6 and 7, Control C to copy, Control V to paste, or Command if you're using a Mac. So, and now run this and we'll see what happens. So, what this did, if you see, is that you can imagine this as that when you tell a turtle to stamp, he gets his belly all covered with a bunch of ink, and then he does a belly flop on the piece of paper. So making a nice big, whatever shape you have, stamp on the board. This is extremely useful for us to when we're working later to visualize what our program does. So I've explained though that turtle is kind of limited. There are a few things, like I mentioned that that it's not great for games. Yes, you can like hit keys and like do like, okay, on this key move in this direction or trigger this event or whatnot, but it's very tedious to do with turtles. It's not great to try to do interactive stuff with turtles. What are turtles pretty good for? Making simple drawings. What it's really good at, what it's really, really, really good at, is spirograph. Anything that's that's a spirograph stuff. What do I mean by that? Well, let's just take. I mean, we've got. So, for instance, a drawing like this one over here. This stuff, turtle. These complicated kind of geometrical spirograph-like stuff. Spirograph being a children's toy for making these kind of spirally designs. Turtles are really good at that kind of thing. Let's see. Well, let's go ahead and kind of show you what I mean. So, Bob dot, so let's see, for, so I'm going to use some stuff that you don't need to know yet. For I in range 0 to 50, Bob dot right, let's do 63 degrees. Now I'm choosing something that's not in that if we do it multiple times doesn't get us in a complete circle. It always is going to be a little bit off. The reason for that is that we want it to be, let's see, Bob dot full, and let's see what happens here. And we'll we'll do 50. Let's see. And just keep running this. And we should be able to see the turtle in action. So here we're kind of making something that looks a bit hexagonal. And you can see that it becomes a bit more intricate. You know, we can increase the, it's going to keep running until it's done. We can increase the size of this so that we can see a bit better. Bob forward 100. We'll make it, yeah, we can keep going with this. Let's go with 141, actually, though. So we do star, so now this makes more of a starry shape. Okay. And that becomes a bit more pretty, but let's add some color into this, okay? Let's go ahead and add some color into this. So let's go ahead and say when you move, bob.color is, let's see. So it's going to be 0, no green. We'll add in red and subtract blue. So let's say 255 minus 2 times I, and then 3 times I. I'll explain what I did there in a second, assuming this works. No, it did not work. Bad color sequence in line 6. What do I have to do to create a new color? See, I told you I have to... Oh, that's right. Right, it's part of the... Right. I always forget this. So turtle with color, if you're familiar with RGB stuff from 0 to 255, turtle assumes you aren't because, you know, you just started coding. So a color is basically made up of 3 colors with an intensity of 0 to 1. Okay? So over here, what we'll do is we will say 0.03 times times I. Let's see now. 0.015 times I. And then 1 minus 0.02 times I. That should work now, I think. Oh, don't reload. Save and run. There we go. Did it catch it? Yes, it did. No, it did not. Too bad. Okay. 1 time 0.02. I hit F5 because that's my reflexive command to run something, not refresh the page. 0.02. Now, if you're busy trying to scratch this, write this all down, don't worry about it for a bit. I will try to get this to you in a second. 1 and then minus. Let's do 0.01 actually. And then, yeah, 0.015. Save and run. Here we go. So now we've got this turtle going, and we'll add in red, and we will subtract blue very slowly. It's going to be subtle, a bit, but the color is changing, becoming more purpley. So now it's become, so there you go. You can see that basically now that there are two colors kind of overlaid. Not as easy to see. Let's go ahead and subtract out the blue much faster. Right? So you can make it change color as we're doing things. Okay. Let's see. Oh, you want to do this on your computer? Give me a second. Okay, share code with all the students. Yes. All right, see what happened. This didn't work last semester, but see what happens when you reload the page. Okay? You should maybe be able to see my code. I'm going to go check. All right, use the student's laptop. See, reload the page. Yeah, you can see it now. Right? Can you copy it down or? Yeah, reloading the page. Should put that in your code history. That work for everybody? Yeah. Yes. I mean, yeah, in your history. But yeah, in your textbook it's there now. Remember. Online and see what's going on. All right. That seems to work. So now, if you're curious as to what the full functionality of the code is, you can go and look up. Turtle Python, and the first course link will be the library, Turtle Python. It will be like all the things you can just do with Python. On the other hand, like Geeks for Geeks, Real Python, there's going to be a lot of resources that just straight up have a couple of really cool things you can do with Python. Well, this one says, let's see, Turtle Python examples. Because again, these kind of things can be very, intricate. They can get very intricate over here, as you can see. A turtle over there for scale. That's what I mean by spirographs. This is the kind of thing that Python that turtles excel at. Now, I know it seems like this stuff seems very simple as to what it can do. And I know the code itself may not seem simple, but like the output can be fairly simple and unexciting. But again, it's a great teaching tool for this kind of stuff. And it livens up the ability for me to do the basics. Lab 3, if you want to, again, you're more than welcome to get head starts on this stuff. Lab 3 does things like drawing the Olympic rings using turtles, and drawing a clock using turtles, and drawing your initials using turtles, getting you familiarized with using the turtle commands. We're going to be using the turtles extensively in our homework and on our exams. If for no other, because again, I believe it's a good pedagogical tool, and also ChatGPT really doesn't do turtles that well. Turns out you need to be able to kind of see your output, I guess. And ChatGPT really can't do that kind of stuff. So, all right. So now what I would like you to do, oh, this can happen, by the way, where basically you get a timeout error because it is working, it is, takes too long. Your drawing gets too complex and takes too long. One of the things we can do to get around that is the speed function. Okay. And this is one of those cases where we, instead of using Bob, I'm going to say, I believe I should say turtle.speed over here. We'll find out very quickly. The speed ranges from 1 to 10 for speed, where 0 doesn't mean very slow. It means actually ignore speed altogether and just draw it as fast as computerly possible. So if you want like near instantaneous, I thought it would do that. Nope, let's go ahead and see. I think it was probably bob.speed in that case. Or maybe it's because I did the output then, I don't know. Yeah, it's bob.speed, not turtle.speed, so give it a second. Again, your web page, this will, because of the nature of programming and the way you can create infinite loops. Oh, there it goes. There it goes. So like I said, if you need to, you can get it going at as literally as fast as it can draw and update the screen. You can actually get it you can actually get like, I think a few 100,000 movements is where I've gotten it without having to adjust the time. Because, again, it's just trying, the reason that the speed is set to what it is because you want to see what it's doing. All right, so for the second part of this activity right now, so I want you to take about 15 minutes, let's say, to go ahead and try experimenting with the turtle on your own. Draw whatever you want, and experiment and just try and have some fun, really. Yeah, that's really it. That's all there is to it. I wanted to introduce turtles, I want to show you, and I want you to try it out yourself. I'm going to pause the recording because I'm going to go around and talk to people. So I liked what I was seeing from a lot of students. Let's talk about color for a second, which is best described by this webcomic by XKCD, which is very, let's see, color models. My evolution of the understanding of color over time. Color is 3 primary colors mixed together, a rainbow, and each color is a wavelength. Unknowable, 3 primary-ish colors, a mix of infinite wavelengths, something about opponent color model, abstract multidimensional gamut. Abstract multidimensional gamut gets worse and worse, and then says, hopefully somebody else's problem, right? Color is actually fairly complicated. And so when you're doing color mixing in Python or on a computer, it actually ends up being annoyingly different because you're using light as opposed to ink. And that changes things. It kind of makes it work opposite of how you would think. So the RGB color model is what you're using. It is an additive color model where basically you add color together to get things. Also, you're really good at sensing green. So, so there's actually a lot of encoding that goes on into it. It's actually a very interesting thing. But notice that if you were to take a bunch of crayons and just, as my 6-year-old does, and just like kind of draw and cover everything up, eventually you're just going to get black, right? But if you take white and mix it together, you're going to turn up all the intensity on the color. You're going to get white, right? Whereas black is the absence there. So it's a completely different color model. So just keep that in mind as you're trying to get the colors you want. All right? Right? We can see over here. You can actually see over here that if you want yellow, you have red and green. Weird, right? It's not. So 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 just keep that in mind. Now the other thing, that's no problem. Experiment, literally experiment. It's, you know. Now the other issue that I saw some students having was, I'll go ahead and, now there's reasons I was using this number. What this does is that I've got what's called a for loop going on over here. Now for loops are going to be the focus and the primary hurdle. First off, they're the primary hurdle that you'll be encountering in this class. Once you get over this, you'll probably be good for the class. For loops are the focus of labs 3, I believe. I think we touched them on a bit in lab 3, but really hammer them in weeks 4 and 5. In fact, that's why weeks 4 and 5 are one assignment, because it's one topic, for loops. So what this for loop does is that it says, effectively right now, is that we've got this variable called I, and each time we do these, and we're going to do these lines 50 times. As we increase this, I is going to be the values 0 up to, but not including 50. So if you change this, so you can get an error. So what I was seeing a lot of is that if students like did this, where like we've got 0.03 times I, and we run this, eventually you'll get an error saying bad color sequence. And what's going on there is that this color model that the Python is using, it's still the same thing, the RGB model. It's just normalize the values between 0 and 1, so you don't have to remember, oh, what's the highest number? It's 255? You don't have to remember that. It's just 0 and 1. But, so 0 is lights completely off. 1 is lights completely on. There's no turning it up to 11. So if you go up beyond 1, it gives you an error. And that's what happens over here. 0.03 times 40, right? So with 40, right, just change it into multiplying that number by 4 instead, right? We removed a 0, we'll change it to multiplying by 4 instead. That becomes 1.2, which is more than 1. So your program says, that's not a good color, I'm going to go ahead and crash because I don't know how to handle that. You know, I'm not one of those mantis shrimps that has really, with those awesome punches and being able to like see more colors than you can. So, you know, they're wild. Mantis shrimps. All right, but anyway, that's why you'll be getting some issues with that. These turtles, again, are very powerful tools. And I mean, a lot of times it's often just simply easier to just simply say the color is like green or blue. Or you can rotate between things. You can also use, if you're familiar with hex codes, 0x, and then you've got two hexadecimal numbers for your, like, if you're familiar with this, I believe you can also use this, 0x, let's do FF0000. I believe this works. Let's see. Did I do that right? I probably didn't do that right. But I'm pretty sure, I know there's a way to use hex codes in this that you can, that just have to look it up. I literally use it one time during the semester and therefore I don't remember about it any of the other times. Regardless, there are multiple ways to do color codes here. And again, it's not something you really have to worry about. Now on the exam, which isn't like tomorrow, it's not next week, it's week 6, I will be using turtles. What kind of thing would you need to know for turtles, as I was saying? Like I mentioned that like it's generally along the lines of select the correct drawing or draw something yourself. In those cases, though, what kind of commands? Do you have to remember about color and all that kind of stuff? Or the shape? I'm a terrible artist. I can't draw to save my life. I mean, no joke. I took an intelligence test once, okay, and it tested like some visual processing area. And I scored in the first percentile. Not the 99th percentile, the first, meaning that if I'm in a room with 100 people, I'm the worst. So I have pity on anybody else who has as bad artistic ability as I do, right? So on an exam, really the commands I limit myself to are up, down, left, right, and forward and backwards. That's what I limit myself to on the exam. And then the rest of it is done with the rest of it is about manipulating it with for loops. So, what? All right, I'll see you all on Thursday, and I see you next.